All right. So all these devices here are referred to as circuit protective devices, but they all have different functions that they perform in an electrical wiring. All right. So the first of all, I'll be talking about the miniature circuit breaker. All right. This is a double pole breaker. These are single pole breakers. Double pole. Double pole means when it breaks both the line and then the neutral wires. A single pole miniature circuit breaker means that it breaks only one line when it operates. So normally we connect the live conductor through the single pole miniature circuit breaker. All right. Now, what the miniature circuit breaker does is to protect the circuit, that is the cables and then the equipment in the wiring, from excessive current. And so to some extent, the miniature circuit breaker protects your property from electric fire. All right. Now, each miniature circuit breaker has a rating, and when wiring, you have to pay attention to the rating of the miniature circuit breaker. If you want to know more about how to select the correct size of miniature circuit breaker for your wiring, kindly refer to my previous video on how to select the correct size of breaker. All right. Usually, the main breaker, the breaker that is protecting the whole wiring, is usually a double pole breaker. Most of the time, depending on the size of the wiring, it is rated 100 amps. Then the single pole breakers protect the individual circuits. Depending on the number of circuits you have a number of the miniature circuit breakers in your distribution box. So these individual breakers protect the individual circuit from short circuit and then overload. The next thing I'm talking about is the residual current device. So all these three are residual current devices. But then we have the RCCB, and then we have the RCBO. Now, this is an RCD. This is also an RCD. These two, how do they work? So let me first talk about the RCCB. So RCCB stands for Residual Current Circuit Breaker. Normally, when you buy an RCD, there should be a test button that you can use to test if the RCD is working. If you want to use this to test, then you have to connect supply to the RCD. Okay, so before I connect these wires, one important thing that you have to know is that unlike the miniature circuit breaker, that you can connect any of the cables to any of the terminals. In the case of the RCD, there is a place where you must connect your neutral, except you have an RCD that doesn't have any indication at any of the terminals. Blue is my neutral line. Okay, so now I'm connecting this to supply. This is live, and then this is neutral. Okay, so it's on now. If you want to check whether the RCD is reliable or not, you just press the test button. All right, so on, you press this one, it should go on. All right, so now we are sure that this RCD is working. Now, the rating of this RCD is 63 amps. And then I also have 30 milliamp here. If we are employing RCD in our circuit, what we should be mindful of mostly is the 30 milliamp here. This is because there is not only one rating for RCDs. Depending on where you are using them, we have 30 milliamp rating, we have 100 milliamp rating, we have 300 milliamp rating. If you are selecting an RCD to protect human beings, then the best rating you should get should be 30 milliamp and below. All right, so now I'm going to demonstrate to you how the RCD works. Okay, so I'm going to connect this load. When I connect the load to the RCD will monitor per the amount of current that this lamp will take. If this lamp is taking 0.02 amps to work, the RCD will make sure that 0.02 amps flows through the live wire, supplies the lamp, and then 0.02 amps flows back through the neutral wire. All right, so in that circuit, the RCD will only permit 0.02 amps through the live and then 0.02 amps through the neutral. And that is what it is going to monitor. That is how it should be continuously. And so the moment an amount of current that is more than 0.02 amp will flow through the live wire, then the RCD will trip. It cannot trip when there is overload. It can also not trip when there is short circuit. Now, this 63 amp rating you are seeing here is just telling you the amount of current that this contact can carry. It doesn't mean that when 63 amp flows through it, it will trip. No. So you should make sure that whatever load you are connecting to this RCD altogether shouldn't be more than 63 amps. And so when you are using the RCD, in this case RCCB, you can't use only this one as the main breaker. You have to use the MCB. So the MCB will be protecting against overload and then short circuit, and then the RCCB will be protecting against leakage. Because this is RCCB and it doesn't offer protection against overload or short circuit, I have to use a miniature circuit breaker together with this one to protect my circuit. Okay, so then a miniature circuit breaker has to come in. As the RCCB is protecting the users, the human beings, from electrocution, the MCB is also protecting the wires and the whole circuit from excess current, which could result from overload or short circuit. All right. So now I have my RCD connected. I have my MCB also connected. All right. But in the case where you want to use this RCD for the whole wiring, then you cannot use the same RCD as the main breaker. There must be a miniature circuit breaker. All right. So assuming you want to use this RCCB to protect the whole wiring, then it means that the total load should not be more than 63 amps. And then there must also be a miniature circuit breaker of 63 amps to go with this one. Now, because this is 63 amps, we can use this one to protect this lamp and another equipment or another load. But then, each of the loads that you will be connecting to this RCCB must have its own breaker that is protecting it. For instance, this 6 amp breaker should be connected to my lighting circuit. In case I want to connect the same RCCB to my sockets, that's my fridge and my televisions and other things, then I will have to use a 16 amp breaker or a 20 amp breaker depending on the load demand to protect those ones also. And so this is the live output of the RCCB. So I have to connect it to the MCB that is protecting my lamps. So here we go. So now the live input to the miniature circuit breaker that is protecting the particular circuit, in this case my lighting circuit, is taken from the output of the RCCB. Now In the case where you are using one RCCB to protect the whole wiring, you can connect the neutral output to the neutral bar in the consumer unit. But in the case where you are using it to protect only some particular circuits, then you have to connect the neutral to all those circuits from this same terminal. All right, so look at how it works. So here, my live to the lamp will be taken from the output of this miniature circuit breaker. Okay, so this is my live output from the miniature circuit breaker, and I will connect it to the lamp. Then this lamp will need live and neutral to work. And because I am using the RCCB, the neutral must be taken from the neutral terminal of the RCC to the neutral. Okay, so this is my neutral to the load. All right, so live input to RCD, live output from RCD to miniature circuit breaker, live output from miniature circuit breaker to load. Then neutral input to RCD, neutral output from RCD to load. Okay, so now if this RCD is on and then this breaker is on, the light comes on. All right, so now let's look at how the RCD works. This load is taking an amount of current, let's say 0.02 amps. What this RCD is doing is that it makes sure that 0.02 amps will flow through the live to the lamp and 0.02 amps will flow back through the neutral. The moment it senses an imbalance in the current that is flowing through the circuit, it has to go off. An imbalance is when the current flowing through the live becomes more than the current flowing back through the neutral. This can happen when there is a leakage in the circuit. Okay. So if I want to connect another load to this load, because it's 6 amps, this one is taking just about 0.02 amps. So I can connect additional load to this load to the same RCD. If I am doing that, then I have to make sure that whatever load I connect, I must connect both the live and then the neutral from the output of the RCD. If I connect both live and neutral from the output of the RCD, then 0.02 amps plus 0.02 amps is what must flow through this RCD, through the live and then back through the neutral wire. All right, so let's see how that happens. I have another lamp that I want to add to the existing circuit, but I want that lamp also to be connected to the RCCB. This should be well insulated. All right. So now I have two lamps now. I had one first and I want to connect another one. Because I have this RCD in the circuit, I have to make sure that the cables to my load are connected from the output of the RCD. That's live from the output of the RCD, in this case, through the miniature circuit breaker. And then neutral must also be connected at the output. So here, because we need short circuit and overload protection, I'll connect this live through the miniature circuit breaker. The same way I could have just looped from the other lamp, line to line, neutral to neutral. It's the same thing. Okay. Then neutral must also connect to neutral at the output here. So now I have two lamps now connected in this circuit. Okay, so if this goes on and this goes on, both lamps work correctly, because though I have added another load, what will happen now is that the RCD will monitor that zero point 0.4 amps will flow through the live and then back through the neutral. So far as that condition is met, the whole system will work. The RCD will stay on without operating. All right. Now, imbalance, imbalance, imbalance. I'm going to practically show you what I mean when I say imbalance in the system. All right. So I'm going to remove one of this lamp, and at this time, I'll connect it in such a way that the live output to the lamps will all be connected through the RCD, through the breaker. So I'll not change anything about the live wires, but I'll remove the neutral wire that is going to the second lamp that I added, and then I'll connect it to a different neutral source. When I do that, what happens is that you will have only one neutral wire here. That is the neutral coming from this particular lamp. Okay, and so what it will mean is that the live cable is supplying two lamps, but the 0.04 amps that is flowing through the live wire, when it is coming back through the neutral, it will now be 0.02. So that creates an imbalance. All right, so in this case, 0.04 amps flows through the live wire to the lamps, but when it's coming back, it's only 0.02 amp that will be flowing. And so there will be an imbalance of 0.02 amps. It means you have 0.4 amps through the live wires, but you have only 0.2 amps going back through the neutral wire. And so the RCD will trip. And though the rating is 30 milliamp, most of the times the operating value is far below 30 milliamp, sometimes as low as 30% of 30 milliamp current should be able to operate the RCD. All right, so let's look at how that happens. Okay, so this goes off, this goes off, and then I remove the neutral wire I added later. Now, this neutral wire, I'll connect it to the main supply neutral wire here. All right, so now you see it is only one of the neutral wires that is passing through the RCD, but you have two live wires connected to two lamps. All right, so now when you switch this on, this one, the RCD will trip. Look at it again. The moment I attempt to switch on the MCB, the RCD will sense the imbalance current. Quickly, it will go off. So that is how it works. The same way, if you connect all the neutral wires from the output of the RCD, but you take the live from anywhere else that is not passing through the same RCD, still it will not work. So let me connect this live wire here, and then let's try to on it again. You see, you see, you see, because zero point 0.2 is flowing through the live wire to just one lamp, but when it's coming back, the lamps are now two, and the two lamps are taking 0.04 amps. So it's 0.04 amps that will return through the neutral, and so that becomes an imbalance between the live and then the neutral. And it is the same thing that happens when there is an earth fault in the wiring. An earth fault means that somehow part of the current that is supposed to be flowing only through the live conductor is now flowing through a metal part of the wiring. And so when you have contact with that electrified metal part, the current that is supposed to flow through your body to give you electric shock creates that imbalance between the live and the neutral to break the circuit. For more explanation on this, you can also watch my video titled "What is RCD?" Detailed explanation. All right, so I've not been able to talk about everything in this particular video, but I assure you that in my subsequent videos, I'll cover the rest of the things I'm not able to do in this one. Thank you very much. Stay connected so you don't miss out on my videos. If you really like this video, please give me a thumb up, comment, and share to others.